Hello friends, Satyendra here, and in this video, let's design the screw jack. So if you see this drawing, this is the screw jack assembly and these are the parts. The part names are listed here. Now if you see the industrial screw jack, these are few examples for the industrial screw jack. And the purpose of screw jack is to lift heavy load for a small height. So first we will complete these parts using this drawing, and then using bottom up assembly approach, we will assemble these parts to complete the assembly. So complete this assembly because the next will be the animation of this assembly. Now let's start with the first part, which is the screw jack body. So let's get started. And to do this, first you go to new, part, solid, assign the name, uncheck the default template and select a metric template. So this is my metric template, millimeter kilogram second. In your case, you can go with this template. So I'll go with this template. Now to create this part, go to revolve, onto the front datum plane, normal, add the datum center line, just like this. Now draw a line. Now this is 140. Now draw the rough sketch. So start from here, just draw like this and close the sketch. Now the dimension. So place all required dimension. So this dimension I need, this dimension is needed, then I need this dimension, then this dimension is required, then this dimension, and then this dimension. Now to modify all these dimensions at a time, go to modify and start selecting all dimensions one by one. So this is the easiest way to modify all these dimensions at a time. Drag it down, uncheck regenerate and start modifying dimensions from here. So this is 70, this is 40, this is 66, this is 185, this is 100, this is 20 and this is 140. Now say OK and your sketch is modified. Now you say OK and OK. Now once again revolve, placement, define, use previous for the previous sketching plane, place a datum center line, then go to reference, select this top surface and this side surface. Now draw the sketch. So draw a rough sketch just like this and close the sketch. Now the dimension, so this is dia 50, but if you see this dimension, it is dia 50 H7. So we understand dia 50, but what is H7? So to understand it, let's see this drawing. So this is your dia 50 H7 and this is the part 1. And if you see this part, this is the part 2. And here also you have dia 50 R6. So this S7 R6 represent a type of fit. So mainly there are 3 types of fit: clearance fit, transition fit and interference fit. So when we assemble these parts, there will be either clearance fit, transition fit or interference fit. So S7 R6 is an interference fit. So for time being you leave it and only focus on dia 50. So now the dimension. So this gap is 10. This is 3. And this is 100. Say OK and OK. Now let's create a section view. So go to view, sections, offset section, select this top surface, normal. Now draw the sketch. So from here till here and from here till here. Say OK. Now rename section as section A and say OK. So your section is done. Now let's add a round. So go to round, select this edge, this is 8 and OK. One more round in the bottom, somewhere here, and this is 3. Say OK. Then the last round, which is somewhere here, and this is 2, and say OK. And this part is done. Now save it and close it. So the first part is done. Now the second part, which is nut, which is this part, and this part sits over here inside this body. So this part will have internal square thread, and square thread is used for heavy load. So let's do this part now. And to do this, go to New, Part, Solid, assign the name, uncheck the default template, and select a metric template, the way we selected in the last part. Now to create this part, go to Revolve, onto the front datum plane, Normal, add the datum center line, just like this, then a line somewhere here. Now this is 50. Now draw a rough sketch, just like this. And close the sketch. Now the dimension, so this is 10, this is also 10, and from here till here this is 45, then this one, so this is 90, say OK and OK. Now go to Extrude, select this surface, Normal, draw a circle. Now the dimension, so this will be 38 minus 7, 31, because 38 is with thread, without thread it will be 38 minus pitch, which is 7, so it will be 31, say OK, flip the direction and select 2 next and say OK. Now this is having one square thread, which value is given here. So the thread dia is 38 and pitch is 7, and for this go to helical sweep, reference, define, front datum plane, sketch, normal. Now go for reference, select this edge as a reference. Now sketch the thread profile. This is 3.5, half of the pitch, and this is also 3.5. Add a datum center line, just like this, say OK. Now go for thread section. So draw a rectangle somewhere here. Now this will be half of the pitch, 3.5. So if you see this image, you can understand it. Say OK. Now the thread pitch is 7, so make it 7. Remove material, see the preview, and say OK. Now let's create a section view. So go to the view, front datum plane, Rename the section as section A and say OK. So its section view is created. Now add some rounds. So go to round, select this surface, press and hold Ctrl key, select this surface and this surface. So this will add a complete round. One more round to this edge and this edge. This is 5 and say OK. Now the last round to this edge and this is 1 and say OK. And this part is done. Now save it and close it. So the second part is done. Now the third part, which is screw spindle, which is this part, and this part fits inside the nut. So this part will have external square thread through which it moves up and down. So let's do this part now. And to do this, go to New, Part, Solid, assign the name, uncheck the default template and select a metric template. So this is my metric template, millimeter kilogram second. In your case, you can go with this template. So I'll go with this template. Now to create this part, go to Revolve, onto the front datum plane, Normal, add the datum center line, just like this, then a line somewhere here. Now this is 22. Now draw a rough sketch. So start from here, come down, then this side, again down, then this side, this side, this side and close the sketch. Now the dimension. So this is 240. This is 13. And from here till here, this is 83. Then this is 65. And this is 38. Say OK and OK. Now the next feature is this hole, which is a non-standard hole. So I'll create this hole with extrude. So go to extrude, select the right datum plane, normal. Now add a circle, just like this. Now from here till here, this is 35 and this is dia 12. Say OK. Now the depth is 2 next in both the direction. So go to second direction and this also you make 2 next and say OK. Now the next feature is this standard hole M12. So go to hole, switch on your center axis, select this surface, press and hold Ctrl key and select this axis. Then go to standard for standard hole. Then from here you select ISO and from here you select M12. Now go for countersink, then shape and here you make it 12 and this height is 30 given and this is 35 and say OK and your hole is created. Now let's create a section view. So go to View, Section, select the right datum plane, rename the section as section A and say OK. So now if you see your hole looks like this. Now the next feature is a chamfer. So go to chamfer, select this edge and this edge. Now the dimension is 10 into 45 degree. So make it 10 and say OK. One more chamfer to this bottom edge, and this is 3 and say OK. Now the last feature is the square thread, which value is given here, 38 dia and 7 pitch. So for this, go to helical sweep, reference, define, front datum plane, sketch. Make it normal. Go to reference, select this, this and this as a reference. Now add a datum center line. Then draw the thread profile. So draw a straight line just like this. Take little extra this side. Now this is half of the pitch. And this is 3 given. And say OK. Now go for thread section. Draw a rectangle inside. And this will be half of the pitch. So if you see this image, you can understand it. Now say OK. Go for remove material, and the pitch is 7. So make it 7 and say OK. And this part is done. Now save it and close it. So the third part is done. Now the fourth part, which is cup, which is this part, and this part sits over the spindle. So the load will be directly attached to this part. So let's do this part now. And for this, go to new, part, solid, assign the name, uncheck the default template and select a metric template. So this is my metric template, millimeter kilogram second. In your case, you can go with this template. So I'll go with this template. Now to do this part, go to revolve, onto the front datum plane, normal, draw a datum center line, just like this, then a line somewhere here. Now this is 45, then draw a rough sketch, just like this, and close this sketch. Now the dimension, so from here till here it is 42, this is 12, then this is 65, and this one 38. Say OK. And OK. Now for the next feature, go to extrude, select this surface, draw a circle, just like this. The dia of circle is 22.5. Say OK. Flip the direction and make it 2 next and say OK. Now the next feature is this small cut, and for this once again go to extrude, onto the front datum plane, normal, go for reference, select this reference, draw a circle somewhere here. Now the radius of circle is 5, so make it 5, say OK. Go for remove material, to next and say OK. Now pattern this feature. So switch on your center axis first, then go for axis pattern. Select this axis, make it 360 degree and say OK. Now add a section view. So go to view, section, planar, select the front datum plane, rename it to section A and say OK. And this part is done. Now save this part and close this part. So the fourth part is done. Now the fifth part, which is washer, which is this part, and this part sits over the spindle inside the cup. So let's do this part now. And to do this, first you go to new, part, solid, assign the name, uncheck the default template and select a metric template. So this is my metric template, millimeter kilogram second. In your case, you can go with this template. So I'll go with this template. Now to do this, go to extrude, onto the front datum plane, normal, draw a circle somewhere here. Now this is 35. Say OK. Now the thickness is 8 and say OK. Now the next feature is this hole. So for this kind of hole, go to hole, switch on your center axis, select this surface first, press and hold Ctrl key and select this axis. Go to sketch, sketcher, datum center line, draw a vertical center line, then a line, just like this. Now this is 25. Now draw a rough sketch. So start from here, come like this, down, this side and close the sketch. Now the dimension. So from here till here, this is 8. Then this angle is 90 degree. And this is 14.5. Say OK. And OK. Now the last feature is a chamfer. So go to chamfer, select this edge, the value is 1, say OK. And this part is done. Now save the part and close the part. So the fifth part is done. Now the sixth part, which is CSK screw, which is this part, and this part sits here. So this will lock this washer with this spindle. So let's do this part now. And for that, go to new, part, solid, assign the name, uncheck the default template and select a metric template. So this is my metric template, millimeter kilogram second. In your case, you can go with this template. So I'll go with this template. Now to create this part, go to revolve, onto the front datum plane, normal, draw a datum center line, somewhere here, one line, from here this side, Now this is 24. Now draw a rough sketch. Start from here, come this side, this side, this side and close the sketch. Now the dimension. So from here till here this is 30. This is 12 and this angle is 90 degree. Now this dimension will be a reference dimension, which is 6. Now you say OK and OK. Now the next feature is a groove cut. So go to extrude, select this surface, normal, draw a center line, an angular center line, one more center line which is normal to that center line. Now this angle will be 45 degree. Now draw a rectangle. So go to rectangle, slanted rectangle. Start from here, just like this, let it be symmetry and place like this. Now make it tangent. So this line tangent with this edge and this line tangent with this edge. Now this gap is 2. Say OK. Flip the direction. Now the depth is 3. Remove material and say OK. Now the next feature is a chamfer. So go to chamfer, select this edge. The value is 1. Say OK. Now the last feature is M12 thread. So go to engineering, cosmetic thread, select this surface, go to standard and from here you select ISO and from here you select M12. Depth, for depth you select this surface and depth you make it 22 and say OK. So this part is done. Now save it and close it. So the 6th part is done. Now the 7th part, which is Tommy bar, which is this part. So this part is directly attached to the spindle to rotate the spindle, and that is how spindle moves upwards and downwards. So let's do this part now. Now to do this, first you go to new, part, solid, assign the name, uncheck the default template and select a metric template. So this is my metric template, millimeter kilogram second. In your case, you can go with this template. So I'll go with this template. Now to do this part, go to revolve, onto the front datum plane, normal, draw a datum center line somewhere here, then a line here. Now this is 12. Now draw a rough sketch. So start from here like this, this. Now draw one arc here. So draw like this. Then move this point to this line. Close the sketch. Just like this. Now go for delete segment and delete this unwanted segment. Now the dimension. So generate all required dimension. So from here till here, one dimension, and this is second dimension, then this angle is third dimension. Now to modify all these dimensions at a time, go to modify and start selecting all these dimensions one by one. So all these dimensions get listed here. Now uncheck this and start modifying all these dimensions from here. So this is 275, this is 62, this is 45, this is 20, this is 12, and this is also 12. Say OK and say OK. Now the next feature is a chamfer. So go to chamfer and select this edge. The value is 1. Say OK. Now the last feature is the knurling area. So to indicate this, I'll create a cosmetic groove. So I'll go to engineering. I'll select cosmetic groove. I'll select the surface first. Say OK and select the sketching plane. Again say OK, OK. Normal. Go to reference, select this top and this bottom as a reference. Now draw one line just like this, one dimension from here till here. This is 100 and say OK. So it will form like a circle. So this area is the knurling area. So we don't create this knurling area as a cut feature. We practically create this knurling area with a standard knurling tool. So no need to specify any dimension for it, and that is why we don't create any feature for this. So this part is done. Now save it and close it. So all the parts are done. Now let's move to the assembly. And for this, go to New, Assembly, assign the name, uncheck the default template and select a metric template. So this is my metric template. In your case, you can go with this template. So I'll go with this template. Now there are two different approaches to do the assembly. The first one is the top-down assembly approach, where we create all the parts within the assembly environment. And the second one is the bottom-up assembly approach, where we first create all the parts and then using assemble, we assemble these parts to complete the assembly. So here we will use the bottom-up assembly approach. So let's start with the first part, the body, which is this part. And for this, go to assemble, select the first part, open. Now for the first part, directly go to the placement and select the default placement. And your part is done. Now let's create a section view. So go to view, section, offset section. So offset section will allow you to create your own sketch for the section view. Say normal and draw the sketch. So draw a line from here till here and till here. Say OK. Flip the direction and say OK. And your section view is done. Now let's go for second part, which is this nut, which comes somewhere here. Now when you assemble any part in Creo parametric, you minimum require 3 constants to fix all 6 degrees of movement. But sometime if your part is symmetry all around, then within 2 constants you can fix this part. The third constant will be automatically assumed. So you will see this behavior in upcoming session. So let's go for assemble. Select the second part. Say open. Now let's switch on the second window where I can see the preview of second part. So this option is very helpful to assemble any part. So select this surface with this surface and then you can tilt here and select this surface to this surface. Now make it coincident. Now go to placement and here you can see that you have only used 2 constants, first constant and second constant. The third constant is assumed. Now say OK. So your second part is done. Now the third part, which is screw spindle, which is this part. So go to assemble, select the third part, open. Now select this surface with this surface, move it up, and then this surface with this bottom surface. Now this should be distance and the gap should be 10. Again you go to placement, and here also you can see that you have only used two constants. The third constant is assumed. So these all parts are symmetry all around. Now the next part, which is cup, which comes somewhere here. So go to assemble, select cup, open. Now select this surface with this surface and this bottom surface with this surface. Make it coincident and say OK. So the third constant is assumed. Now the next part, which is washer, which comes somewhere here. So go to assemble, select washer, open. Then you select this surface with this surface, and then this bottom with this surface. Change it to coincident and say OK. Next part is CSK screw, which is this part. So go to assemble, select the screw, open it. Now select this surface with this surface and this surface with this surface. Now make it tangent. Now still the part is not fully constant, but for time being just say OK. Now to make it constant, first I will hide these features, and then I will once again edit it. Now switch on your datum plane and go for third constant. Then select this datum plane with this datum plane and say OK. So if you don't hide this feature, then you will have n number of datum planes and you will be totally confused while selecting it. Now the last part is the Tommy bar, which is this part. So go to assemble, double click the Tommy bar, and this way also you can open the part. Now select this surface with this surface. Once again I need to select a datum plane, so I'll just say OK. So I need this part with Tommy bar, so I'll hide this feature and this feature. Now I'll edit this feature. Now I'll select this surface with this datum plane, make it distance, and then you drag this part this side. This value is 29.5. Now this is fully constant. So here also the third constant is assumed. Say OK. Now unhide all other features. Now if you go to front view, Your view is matching with this drawing. Now just need to update the section view. So edit the section view. First I'll change the name as section A, and then go to models, go to third option and select this handle along with this CSK screw and say OK. So I removed these two parts from this section. So now your assembly view is exactly matching with your drawing view. So your assembly is done. So complete this assembly because the next will be the animation of this assembly. So this is how we do screw jack assembly in Creo Parametric, and I hope this video will be helpful. Now you can like this video if you find this video helpful, and I'll see you in my next video. Thank you.